Hey guys, in this video we are going to be computing the Gaussian integral, the integral from minus infinity to infinity of a times e to the minus bx squared dx. So the first step in this is just to define this integral. So we'll say that I is equal to this integral. So I squared would just be equal to the integral from minus infinity to infinity of e to the minus bx squared dx times integral minus infinity to infinity of e to the minus bx squared dx. Well, what's to stop us from changing the variable in the second integral, right? We can change this from x to y. So let's go ahead and do that. So this becomes the integral from minus infinity to infinity of e to the minus bx squared dx times integral from minus infinity to infinity of e to the minus by squared dy. Right? And so here we can then go and combine these two integrals. We can get minus infinity to infinity, minus infinity to infinity of, I'll pull our a squared out front, of e to the minus b times x squared plus y squared dx dy. So this integral, while it seems like it would be scary, it's still doable because we can now transform this into polar form. We can say that r squared is equal to x squared plus y squared, and that means dx dy is going to transform into r dr d theta. Right, when we go to polar form. So this integral then is going to have be a squared from 0 to 2 pi. Integral r starts at 0 and goes to infinity of e to the minus b r squared r dr d theta. Well, since theta isn't anywhere in here, we can automatically do the theta integral to get 2 pi. So we get 2 pi times a squared, integral from 0 to infinity of e to the minus b r squared r dr. Now, we can see this integral easily evaluated with u substitution. So we can say that u is equal to minus b r squared, so that means du is going to equal to minus 2 br dr. Well, we do have, let's see what we have. We have r2, we have our rdr, so we have these right here. So that means we're going to have to change r2 rdr to negative du divided by b. Right? And so we can do that. So our I squared is equal to pi times a squared times, and now we have our negative divided by b, integral, when we plug 0 into this, we get 0. When we plug infinity into this, we get negative infinity of e to the u du. This is an easy integral to evaluate. Minus pi a squared over b. And now this would be, when we plug everything in, it would be 0 minus 1. So, drum roll, we get I squared is equal to pi times a squared divided by b. But we're not looking for I squared, we're looking for just I. So take the square root of both sides. We get I is equal to the square root of pi divided by b, all that times a. Okay, and so that is what the integral from minus infinity to infinity of a times e to the minus b x squared dx is equal to. Hope this was helpful, and hope this keeps the video on problem 1.3 shorter.